Okay, so question 9 is where it starts to get a little bit tricky. Okay, a little bit very tricky in this exam. It starts to bring into a lot of calculus and a lot of, how would you put it, out of the box thinking sort of thing. So what we've got is we've got a graph F, which I'll highlight in red, which corresponds to this rule here. And then we've also got this graph in green, G, which corresponds to the AX. So this bit just here. So the area of the shaded bit is 64. That's given to us up here. And we need to find the intersection, the value of M, and we also need to find the value of A, which appears in these equations here. So we're told the intersection of these two graphs occurs at 0 and at M. So what that allows us to do is sort of set up that x cubed minus ax equals ax. So all I've done is I've let the graph of f of x equal the graph of g of x. So if I now subtract ax from both sides, I get something along the lines of x cubed minus 2ax equals 0. Now if I sort of pull that x out the front, I'll get x squared minus 2a equals 0. So null factor law says that x equals 0, or this little bit in here equals 0. So we've already been told that an x equals 0 happens and that a is greater than 0. So now we need to go hunt down the a part of things. So we're told that x squared minus 2a could also equal 0, or should equal 0 at some point, you'd hope. So we can get this in terms of a and m, because we know the intersection occurs at m. So if we sub m in here, we should get m squared equals 2a. And this should be pretty helpful later on when we're getting towards the end of the problem. So we've got something relating m squared and 2a. So m and a are linked in that black box there. So let's see what else we can do with this this information about 64 up here. So from the previous slide, I'm just going to write it down again. We had that m squared equals 2a. And now that we've got this area here is 64 units for that area there. So how can we go about tackling this? Well, we've got a shaded region between two curves, so we can use calculus to find that area. So calculus says we're going to integrate from 0 to m of our upper curve minus our lower curve, and that's respect to dx. So for us, this is equal to 0 to m of our upper curve. So our upper curve is g of x, which we had in green on the other slide. So g of x is up here, so we're going to have ax, and then we're going to subtract away from it our lower curve, which was f of x, which is this guy. So we're going to subtract away x cubed minus ax, and it's still again dx. So hopefully you can see that we're going to have from 0 to m of ax plus ax, so we're going to have 2ax minus x cubed dx. So let's go ahead and we'll find the antiderivative of that. So we're going to have 2ax squared on 2 minus x to the power 3, x to the power 4, divide 4. And we're going to evaluate that between 0 and m. Now, this 2 and this 2 will cancel. So what we'll be left with up here, we'll just zoom sort of up to this part here now. We're going to have ax squared minus x to the 4 on 4 evaluated between 0 and m. So again, our fundamental theorem of calculus says that's the same as f of m minus f of 0, where, you know, f dashed equals f, our previous one. So f is the antiderivative of that function. So this just turns out to be am squared minus m to the power 4 on 4 minus, well, that's just going to be a times 0 squared minus 0 to the 4 divided by 4. So that entire thing is just big fat 0. So we've got now our area, because that's what this is 64. So 64 equals am squared minus m to the 4 on 4. We have a link up here that links m squared to 2a. So what we can do here is we can say m squared on, so we can say wherever there's an m squared we can put 2a in. So we should be able to get that 64 equals a times 2a minus, this is just 2a squared on 4, which is the same as 2a squared minus 4a squared on 4. The 4's, whoops, let's get that red out. The 4's will disappear, and we're just going to be left with 64 equals 2a squared minus a squared is a squared. Therefore, a equals plus or minus 8. However, a greater than 0. So, you know, but a greater than 0 implies a equals 8. Then in this dodgy little box, I'll just find the value of m. So if m squared equals 2a, we've got m squared equals 2 times 8 is 16. Therefore, m equals plus or minus 4. But again, m from our graph greater than 0. So m greater than 0 implies m must equal 4. So our answers, which I'll chuck down in this cloud, is that a, small a I should say, small a equals 8 and m equals 4. And they're your answers.